Okay, this is section 1.3, part 2. Part 2. In this section, we're going to be working with linear functions again. Okay, we're still working on lines. This one's just a little bit different. Okay, I'm going to start off with this definition: line of fit. A line of fit is when we have a scatter plot. Okay, and we'll go through what a scatter plot is in just a minute. In a scatter plot, we have a line with approximate, sorry, that's an I, approximate relationship. Okay, so in a scatter plot, we have a line with approximate relationship. Okay, and I'll go through again what this means here in our example down below. But first, we have steps for finding a line of fit. Okay, well, the steps are: number one, creating a scatter plot of whatever data we're given, of data. Okay. So first step is creating a scatter plot with the data. The second step is to sketch a line. Of fit through those points. And that's where this approximately comes in. Okay. Approximately through a line of best fit, or through the points that show our linear relation the best. Okay, part 3 is on that line that we drew. We are going to choose 2 points on the line of fit. Okay, so on that line that we drew through our points, we're going to choose 2 points on that line, not necessarily 2 points of the points we graphed, but 2 points on that line. Finally, we're going to write an equation of that line. Okay? Of that line. And that goes back to 1.3 part 1. How do we write a line? Well, the equation of a line is y equals mx plus b. Okay, and we need the slope and y intercept. Okay, so keep those 2 things in mind as we are moving through this lesson, is we have to find the slope and the y-intercept of our line of best fit. Okay. Move into our first and only example of this lesson. Okay. I'm going to show you guys how to make a scatter plot using the stem and leaf data. So with our information over here, we are going to graph that over on this graph to the right. Okay, and then we'll answer the questions below. So let's graph this. Notice our femur length, that is our x, and our height is our y. Notice, right, that's our y, that's our x. It's important to know that. We have to get these numbers onto our graph over here. Now to do that, I need to think about it a little bit. I need to make sure I can get every number on that graph. So in doing so, I want to look at what's my lowest number. My lowest number for femur length is 30. And what's my highest number? 50. 50 is my highest number. Okay, so I'm going to start at 50, and I have to make sure I can get through. I'm going to start at 30 and make sure I can get through 50. To start at 30, I need to do what's called creating a break. Break goes through something like this. Okay, and we can start our graph right here at 30. So instead of starting, let's say, counting by twos, we start at 2. I'm going to create a break that starts at 30. Okay, so right here is my 30. Now I can do a couple different things. I can count by 5s, I can count by 10s, I can count by 2s, I can count by 4s. I have to make sure I get to 50 though on my graph. Okay, and that takes a little bit of thinking here. What I'm going to do is I am going to count by 2s. Okay, 30, 32, 34, 36, 38, 40, 42, 48, 44, 46, 48, 50. And I will get there, okay? But in doing so, I'm going to kind of skip a line, every line. So that's 34 is right here. 36. Okay, and I kind of have to write small. 38. 40. Oh, sorry. I already messed up. Hey, I started by counting by 4s, and then I wasn't consistent. Hey, that's okay. You just saw your teacher make a mistake. I'm going to fix my mistake, though. Okay, so every 2, I'm going up 4. So that has to be 38. This has to be 42. This has to be 46. And then finally, 50. Okay, so I created my x graph, or my x coordinates. That's good. Now I need my y. And again, I need to find my lowest value and my highest value. Right here's my lowest, and right here's my highest. Okay. It doesn't always work like that, where your highest x value is going to be your highest y, or your lowest x value is your lowest y, but in this case it does. So again, I need to create a break. That's what that's called. And to do that, do something like this. Okay, so right here is going to be my lowest point, and that is going to be, I'm not going to start with 141. That's kind of a weird number. I'm going to start with 140. Okay, and I'm going to go, I need to make sure I get up to 195. I'm going to count by 5s. Each point is going to be 5. It doesn't have to be the same as my x. Okay, it does not have to be the same as my x. It has to be consistent though. So here's going to be 150, 160, 170, 180, 190, and I have to get up to 195, so I have to go up to 200. Perfect. Okay. So, a couple things we learned. We learned about how to make a break. I might have made mine a little different than you've seen in the past, but it gets the job done. Okay, you understand what's happening. Now, I have to graph each and every one of these points, which I know is kind of time-consuming and seems a little like a waste of our time, but it's okay. We'll get through it together. So, when x is 40, okay, I'm going to do blue points. No, blue is bad. I'm going to do red. When x is 40, y is 170. So I go to my x at 40, and I have to make sure I get exactly right up to 170, which is right there. Okay, there's our first point. Next is 45, and then 183. So kind of have to think, where's 45? Okay, 45 is here, it's in the middle. And then 183. That's kind of going to be a little bit of a guess. It's going to be somewhere like right in there. Okay. Next is 32. 32 and then 151. So 32, go to X is 32 and go up to 150. And then just right above that, it's going to be 151. Our next point is 50 and 195. That one is a pretty easy point to plot. It's right on our mark. Okay. Our next one is 37 and 162. 37 and 162. Right about there. Okay, next is 41 and 174. 41, 174. Right about there. Next is 30 and 141. That's our lowest point. Right there. Good. 34 and 151. Okay, 47 and 185. 47 and 185. And then 45 and 182. Okay, which I kind of already have a point there. Okay. Now comes that line of best fit. And if you have a straight edge, now is the time to use it. I do not have a straight edge on my smartboard here. I really wish I did. Actually, I might. No, I really don't. Shoot. So, I'm going to do my best at making a straight line. You need to use a straight edge. Okay, I'm going to make my line of best fit. Now, a line of best fit, what that means is we have to go through those points to the best of our ability on a straight line that shows some going up and some going, or some above the line, some below the line, some through the line. Okay, our line of best fit would not be something that looks like this. That would not be a good line of best fit. Okay. Same with. Oh, I can't even rotate it. I'll delete it though. I think I'll delete it, maybe not. Okay. Delete. I want. Oh, maybe that's it. There we go. Okay. Whoa. My bad. Let me get this figured out. Okay. Woo, that was a close one. I thought I was going to lose something there. Okay, that copy, cut, delete thing, that's going to stay there because I'm not going to mess with this too much. Our line of best fit, though, it looks like it's going to go somewhat like that. That was freehand. And I must say, wow, I'm impressed by myself right now. Okay, I'm really happy with that line. You can use a straight edge. Anyway, so we have our line, and that's where this approximity comes in, because not everybody's going to have the exact same line. All right? To make, what do we have to do? Now we have to come up with an equation. Oh, actually, no. It says, does the line, does the data show linear relationship? And it does, right? It looks like the longer your femur length, the taller you are. So, yes, it does. The answer there for that is yes, it has linear relationship. Okay. If so, write an equation on line of fit. Yep. Okay, so now we're going to write that equation. We're going to write an equation of that line. How do we do that? Well, we need 2 points on that line. Right? We need to create an equation that says y equals mx plus b. Start with finding 2 points on that line. That's not necessarily 2 points that we grabbed. 2 points that kind of match that grid up perfectly. I know 1 point is right here. Okay, why? Because it was exactly at 50, 195. So that's going to be my first point. I'm going to write that over here. I'm going to say 50, 195. That's a great point to use. What else does that line go through? I'm going to say this point right here. I'm not going to go in blue. I'm going to say this point right here looks to be somewhat close in our line of best fit. And that's 34, 155. 34, 155. Okay. Again, that wasn't a point that we plotted, but it was a point that the line went through perfectly on the grid. Now we have to come up with our slope, our y-intercept. Let's first come up with our slope. How do we find slope? I don't want to count up how many that is and over how many. That seems like a lot of work. Instead, I can do I can use our equation. Our equation is y2 minus y1 over x2 minus x1. Okay, that's how we find slope. So our y2 is 155. So our equation here is going to be 155 minus y1, which is 195, minus 195, over my x2, which is 34, minus my x1, which is 50. Okay, and I can do this math. 155 minus 195, that's going to be a negative 40. Okay, so it goes up at a negative 40. No, that doesn't make too much sense, but we'll see. 34 minus 15 is an easy negative 16. Okay, that can be simplified. A negative over a negative, that's going to be positive. Okay, that makes a lot more sense. But 40 over 16 we can divide by 4. Actually, we can divide by more than that. We can divide by 8. We can divide by 8, can't we? 40 divided by 8 is 5. And 16 divided by 8 is 2. So we're left with a positive 5 over 2. That is our slope. That's a good thing to know. So what do we know? We know that y is equal to 5 over 2. X plus, we do not know b. We have no clue what b is yet. How can we find b? What we can do is take one of our points. I'm going to take 34 and 155. I'm going to take those 2 points and I'm going to plug it in to x and y. So 34 was x. So our new equation is going to say 155, because that was right here. 155 is equal to 5 over 2 times 34 plus b. Okay. Take out your calculator. Calculators will be needed when we're working with high numbers like this. 5 times 34 is 170. So we're going to be left with 155 equals 170 over 2 plus b. Okay. 170 divided by 2, that's 85. So we're left with 155 equals 85 plus b. And I'm running out of room. 155 minus 85 is 70. So 70 is equal to B. So our new equation, after all of this mess, right, we had a lot of math, is y equals, our slope was 5 over 2, x plus 70. There's our equation of our line of best fit. Okay? A lot of math that was had there. That's okay. Sometimes we need a lot of math. All right, you guys work on the next examples. Try your best. That is the only one I'm going to go through.